Tutorial 6 that I'm preparing for the playlist called Elementary Structure Analysis Problems using the 3D Experiences FEA platform. In tutorial 3 specifically, I talked about an issue which exists when you have a frame structure and you try to analyze it. And I proposed several different strategies. In tutorial 4, I use the impose points functionality that can be used. In tutorial 5, I proposed a weld connector at the juncture where things meet. And now I would like to show you a different way of handling that, a different strategy, which is based on joining the whole thing. However, because you cannot put directly forces and boundary conditions, in our case force, on nodes in this program, you're going to create a group which has that node in it, and then apply the force on that group. Okay, let me remind you that the FEA solver within the 3D experience is the Abacus CAE or Abacus program, and there they don't call it group, they call it sets. Okay, so in this particular tutorial, I'm looking at the same geometry that I looked at tutorials 3, 4, and 5. It's a 2D plane frame structure, and what I'm going to do is I'm going to create this thing as a wireframe, made of 2 lines, and then create a manual group at this location, the node at this location, which will be manually picked, and then based on that, we can actually put our force on that group. Now, because we're dealing with beam element, I showed this particular slide in pretty much all of these things. It shows you how to display different things associated with the beam structure. All right, let's go ahead and do that. I'm going to be joining everything together. Therefore, I have 2 options. I can do that thing as a sketch and then go join it, or I can do it as a wireframe made of 2 lines. And I'm going to do that as 2 lines. Because I need join at some point, I will do this thing directly in generative shape design instead of part design. Makes no difference. If you do it in part design, you have to go to the generative shape design to join them together. But I'm starting in generative shape. Okay, let's go ahead and create our lines. So the first line is going to start down here. It's point and direction, and the point is going to be made 0, 0, 0, and the direction is direction Z, height of 10 inches. Okay. The second line is going to start over here and go that 45-degree angle. So let me go ahead and make a line and point and direction. This is the point. And to specify the direction, one way is to put the cursor in the direction box or input area, edit components, and I put a 1 and 1 here for Y and Z. That means a 45-degree angle. You can see that. And the length is 10. Very good. The cross section is circular, so I don't need an orientation point, by the way, because this is a 2-dimensional structure, frame structure. I can look at it from the front, but it's okay. It's a 3D view. Now, we want to join it. So click on the transform and join these 2 lines. All right. Okay. And then we're going to do the following, apply material to it. So let's go ahead and apply, select the tools, create a material. I'll call this thing tutorial 6, and say, okay, it's going to create it. But there are no numbers in it, so I have to put my own numbers. There's tutorial 6, you can see that. So I select this and drag it to that, green check mark, and close this. Notice that it is created down here, but there are no numbers in it. So left double click on it. You go to structural, Abacus multiphysics, mechanical, elasticity, elastic, 29,000 psi for Young's modulus, 29,000 psi. Sorry, KSI. This is for steel. 200. Sorry, 29,000 KSI. Yeah, 29,000 KSI. Poisson ratio 0.3. Don't need it, but put it in there anyways. Now, we're gonna go to the structure model creation because we want to mesh this thing. Empty FEM. You select the join. Oh, sorry, empty FEM. Select the mesh tab, and beam mesh. Select the join. Everything is going to mesh. Size of the element is 1, so it's going to be 10 elements here, 10 elements there, and we say okay. Now, if you want to make sure that there are no duplicate nodes here, here's what I'm going to do. I'm going to say, okay, let me go to the, first of all, right click visibility manager, and don't show me the part, just show me the mesh. And I don't think it has been meshed. Okay, so let's try it again. So display, what's that? Visibility manager. All right. One thing, it looks like, let's update this thing. Yeah. So there we are. Okay. So now we're going to hide the shape. There we are. Okay. Now, if you want to see the elements, element numbers, when I do this, I go to the mesh visualization. See that? Mesh numbering visualization. For example, if I zoom in and I put the cursor over here, it says node number 1. If I do it on the other side, it should also be node number 1. It is, because these are joined. And if they were not joined, there will be duplicate nodes here, unless if a particular checkbox is not removed. But please, if you're wondering what checkbox I'm talking about, look at tutorial 5. It's described there. But anyway, it is okay. So these are all good. Now, there is also the group, there is also the, before I do that, let me also describe the profile of the cross section. So here is on the properties, beam profile, circular, radius 0.5. These are all immaterial to our problem, but we have to give it a value. So I'm consistent with what I put on the PowerPoint. Now make a section, beam section, select the join. You can select the join, and profile is number 1, and you say okay. And if you want to see that three-dimensional effect, what you do, you click on the display, display preferences, and show it to me as a solid. You can see that. But anyway, so I don't want anything here. Let's get rid of this. All right. So, oh yeah, now we're going to create our group. Notice that there is a tab here called group, and that is what this slide is about. Okay. Same, in the same place that you are where you meshed, you have group. You click on it. And now there are different ways of creating group. This is the manual group. You click on it. You go pick it. So content is a node. So go and pick a node right there. This thing exactly is halfway between those things. If I select it, notice that one node is selected. And then I say, okay. So I have a group here. And I can use this group. This group has only one thing in it, one node. And later on, I can put the load on this group. I cannot put it on the node, but I can put it on the group, or Abacus user call a set. Okay, that's fine. Now we are done here. So we're going to go to structural scenario creation. Let me select my model, FEA model. Good. We update everything, by the way. Oops. Oh yeah, cancel that. Yeah. You know what I forgot to do? Procedures, select the procedures, and it's going to be static perturbation. Say okay. Now update. It's going to be fine. All right, I forgot to select my procedure. I use static perturbation, which is literally linear elastic static step. That's what it is, essentially. Now, we are going to apply boundary conditions. So boundary conditions, what is that? Boundary condition clamp at this end, at that end. Okay. And now we're going to say force, load, a force. Notice that I cannot select nodes here, but over here, the support, you can use the pull down menu, say group, says, hey, I'm going to put this thing on a group. And which group? There's only one group that I have. It's right here, this manual group 1. Say okay. And then put 1,000 PSI. 1,000, not PSI, 1,000 pounds. There we are. And it will work. Okay, so let's check it out. First of all, under simulate, let's check model and scenario check. Unless I forgot something inadvertently. And this is the scenario check or simulation check. So this group is very important. And so one of the reasons that you can use it is that because you cannot put stuff on nodes and elements, if you put them in a group, then you can actually put them on those entities. Okay. Not directly on a node or an element. Okay, this should be okay. Simulation check status. Yeah. And then once it's done, then I'm going to simulate. This essentially wraps up that tutorial 3, where I describe some issues and propose 3 strategies. There are other ones too. The strategies were impose points, and then there was a connector, connector, and then here it was using a group to do that. And as I said, there are other ways of doing it, which is fine. So let's go ahead and run it. Nothing fancy. It's just this is gonna bulge out, just like it happened in the other models. And because it's a 2-dimensional problem, there's no reason to look at it in 3D. So I'm gonna look at the front view, and we can see the deformation shape. This group is also important when you want to extract information from a certain number of nodes or elements. Then you just create groups and then say, okay, give me the results for that particular group, etc. Okay, this is pretty much done. Extracting results. Yep. It is done. Okay, close. And there we are. If you look at this thing, view from the front, here's the front, it puts it in 2-dimensional effect, 2-dimensional viewpoint. And yeah, that's pretty much it. Move on.